A data engineering team is auditing their GDPR compliance processes, specifically regarding the deletion of sensitive user data from Delta tables. The team currently executes delete statements on two related tables to propagate user removal. Assuming the user ID is a unique key, does executing this delete logic ensure that the target records are entirely unrecoverable and inaccessible? If not, why?
All right, here's the question. A solution architect is designing a platform for managing teams' projects. The company requires the solution to use the ACID properties of the delta delete command. Which of the following statements is true? Option A. No, the ACID properties of the delta delete command only apply when used within a merge operation.
Option B. No. Records remain queryable through Delta Lake's time travel feature until a vacuum command cleans up the associated physical data files.
Option C. Yes, the Lakehouse architecture uses enforced foreign key constraints to maintain strict data consistency during deletes. Option D. Yes, Delta Lake's ACID compliance guarantees that delete operations immediately and permanently scrub data from all storage layers.
Option E. No. The Delta change data feed functionality is restricted to capturing only row inserts and modifications, ignoring deletions.
Let's think about how Delta tables handle deletions and transaction histories. When you delete rows in a Delta table, the transaction log is updated, but what happens to the underlying data files? Consider how data retention and historical versions work in a Lakehouse environment.
In my view, the correct answer is option B. Here's why. In Delta Lake, the delete command provides ACID guarantees, ensuring that the operation is atomic and consistent within the transaction log. However, this does not result in the immediate physical purging of data from the underlying storage. Because Delta Lake maintains a history of table versions, users can still access the deleted records using time travel until the vacuum command is executed to permanently delete files that are no longer referenced by the current state of the table. Let's look at why the other options are incorrect. Option A is incorrect because delete is natively ACID compliant on its own. Option C is incorrect because Delta Lake does not enforce referential integrity via foreign keys. Option D is incorrect because delete does not physically purge the data immediately. Option E is incorrect because the change data feed does indeed support the tracking of delete operations.
As an exam tip, always remember that logical deletion in Delta Lake is separate from physical removal. Time travel retains historical data until vacuum runs, which is a critical detail for compliance scenarios like GDPR.